Welcome to our webinar about CloudFormation. My name is Ben Bridts. I work at Cloudar, and I've been working there for a little more than 5 years now. I've been using CloudFormation ever since I started there. So I will try to talk a little bit about all the things that I learned. And together with me, I have Patrick. Patrick, maybe you can introduce yourself a little bit.
Hi, good afternoon. I'm Patrick Sard. I work at AWS as a solutions architect in Belgium, and I'll be joining you for and joining Ben for this webinar to also bring my own experience.
Thank you. So we'll be talking about CloudFormation, as the title will show you. Our focus is going to be on a few practical tips. So we'll try to cover a broad spectrum of things and give you resources to learn more and dive deeper. You can ask us questions anytime. There's a questions tab in the webinar view, and we will try to answer them whenever they fit what we're talking about. And we're going to first be talking a little bit about just what is CloudFormation, how do I write the templates. I'm going to show you how to test and deploy that, how you can add your own resources to that, and at the end we will also talk a little bit how you actually structure templates if you have more than one. So first things first, what is CloudFormation? CloudFormation is infrastructure as code, where you start with putting everything you want to set up inside of AWS, inside of a template. That template is either written in JSON or in YAML. Then you can upload that to AWS, and then the CloudFormation engine will take that and will set up all those resources for you. And it will try to be smart about it, so it will do things in parallel where it can. It will know about dependencies, and it can give inputs and outputs from one resource to another one. And I think Patrick has some tips for us.
All right, so indeed, you have the choice of language, like Ben mentioned. You can write it in JSON or YAML. Well, JSON is good for machines, not so much for humans. So YAML is definitely your choice in this case to write your own templates. And the good thing is that YAML also brings you another nice feature, which is you have comments that you can add in your template. So that can be pretty handy. The second thing is that, which is also important, is that you should consider your template as any code artifact. So there are two aspects to it. So you should manage it in your source version control system, like you do for normal code artifacts. But you should also use the same template across all your environments. So, and we'll talk about different mechanisms that allow you to do that. But that's really important. So don't have different templates for dev, test, acceptance, and prod, but there should be a single template, like you have a single version of your code for each of those environments. So do you have questions at this stage? We'll show this question mark all along the presentation. You will see this line coming back again and again. And the reason for it is to remind you to ask questions in the chat if you have any, and we'll try to watch as we go if there are any questions that need to be answered. I don't see any for now, so let's go ahead. And let's talk about how to tackle the creation of a template. So, well, let's look at first the anatomy of a template. So there are multiple sections in a template, and well, first the most important one, resources, is the only mandatory section in the whole template. So all the other ones are optional. You can of course use them, and sometimes they're quite handy. So you can specify template version. You can specify description for your template. You can provide metadata information. We'll see in some cases where it is important to use that section. You can provide input parameters. So if you need to provide some options to configure your templates, and then use different other sections, either to specify different list of things, of items that you could use based on the specific region, for instance, that you're on, or use different configurations in your template, depending whether you're configuring an environment for development, test, or production environment. And of course, you can provide also output so that, well, first it's visible to the consumer of the template, but that can also be values that are being exported and then can be shared with other stacks. So let's have a look at an example. So if we look at this example, where we have basically, like you can imagine from the name of it, we configure an EC2 instance, we specify its type, which is of type EC2 instance, no surprise, and then we need to provide a couple of properties for CloudFormation to know exactly what to do about it. So it needs to know which image ID we want to use, it needs to know which instance type we would like to use, and if we need additional configuration items, like for instance, it would be nice to make sure that not everyone can access our instance or SSH into it, and specify an EC2 keeper for that. So that's the first example. So of course, it's, as you can see, all the values are hard-coded. So it's probably not the best way to do it. So if we look at the way we could improve that template, where, for instance, we could pass some configuration items as references. So in this case, we configure in the section of, well, in the same section of the template, but another part of the template or security group, and then we pass it as a reference to configure our EC2 instance and leverage the already created security group, which this kind of reference, by the way, creates a dependency. So the EC2 instance creation will wait on the EC2 security group creation to take place. So now we can, of course, go a step further. We could, for instance, ask as an input parameter the instance type. So maybe we want to use T3 small instance, but maybe we want to use something else to actually run our EC2 instance. The same way, we can ask the end user to specify their own EC2 key pair. Maybe they already have created one, and they want to reuse that one to configure to SSH into that instance. So that could be handy as well. And well, we showed reference, the reference built-in function as an example, but there are other functions that you can use and that can help you create your and write your own templates. So to name a few, you can use getTag to access the attribute value of resources that have already been created in your template. You can use sub or join to actually, well, in one case, substitute variables in a string, and in the other case, concatenate strings together with delimiter. And we'll see another tip later on this. And then you have a number of additional functions like base64, for instance, which is mostly used when you need to pass in user data information to your to launch to configure your EC2 instance at launch, and a couple more. We'll see some examples later on. And I think that Ben now has some tips for us.
Yes, I have some tips about using that. For example, one really important tip when you start writing CloudFormation is that a lot of resources have the option to specify a name. So that can be, for example, a database, that can be your S3 bucket. And it's important to keep in mind that it's most of the time not a manager parameter, and that CloudFormation can actually name those resources for you, and that you should let CloudFormation do that if that's an option, because that will allow you a few things. One of them is some resources are either unique in a region or unique in an account, or unique in globally. If you let CloudFormation pick that name, then you know that it will be not conflicting with anything, and it will allow you to deploy the same template multiple times. In the same way, some resources, even if they're if it's okay to pick your name because they're tied to your region and account, if you want to do updates of that resource, and for that it needs to be replaced, CloudFormation will also always first create new things and then destroy the old ones. So if that resource would have the same name, it would not be able to create a new thing first. So you would have to do some strange things and to do updates in 2 steps just to be able to replace things. So if you If you don't pick names, then you don't run in those problems. And similarly, if you're trying to deploy things in multiple accounts and multiple regions, you can use CloudFormation pseudo parameters, which will allow you to get some of the values that you normally would hard code, or that will be dependent on where you are running, to get that from CloudFormation itself without having to put it in your templates. If you're writing templates, you don't have to dive in immediately and start copy-pasting things from examples. You can always click everything together in the console first, get a feeling about this, how the service works, and then convert that by describing what you actually created, and convert that into a CloudFormation template that you can use later and to make it reproducible. And one last thing, we mentioned functions. If you're going to use example templates or writing your own, you might see a lot of things with join. Whereas there's a subfunction that will make it much more readable later. A few examples of these parameters are, these are the full list of the pseudo parameters. The account ID is a really useful one. The region and the stack name are all things that are really useful to use here. Also, the no value one is one that you can use if you have a condition and you want to not specify the else of that condition. You just want to use a default, then you can put if there's no value there. And for sub and join, the reason that we mentioned that is that this is the difference between writing it in those two ways. If you write it as a join, you will get a very long piece of code where you combine strings together to make an RN, where you use those references, for example, with the partition and the account ID. Whereas if you do it in a sub, you don't have to specify ref in there, so that also works for the resources. You don't have, it's not only just for pseudo parameters, and it will just be one long string that's very easy to read. And there are more sections that are actually specified there. There's an inner rules section that's not in the official CloudFormation documentation because it's part of service catalog. It is in official service catalog documentation, which you can use to add extra validation on top of the parameters. And we talked a little bit about starting in the console first. You don't have to actually necessarily completely write your template after you click something together. There's a great tool, Former2, which you can use, which will can scan your AWS account, and then it will also take that and give you either a CloudFormation template from that, or a Terraform template, or a CLI script that you can use to make that repeatable. This is an example of that rules section. So you can add the rules there, and then it will show you these. Sorry, you can add the rules there. In this case, we have two parameters. We're going to do something that's a really bit silly. Going to make sure that they always are exactly the same. And then we have some extra functions like equals, and then we can get an error when we try to deploy that. This is it's going to be more useful if you do it the other way around. If you say, if one is empty, for example, then you have to fill the other one, but you can make smarter rules here and make it easier for your users of your template to not make mistakes. With that, another reminder of questions. I've already seen the question. There was a question about circular dependencies. We'll come back on that later. We have a slide for that. One question I have, Patrick, for you is, I've written my template. How do I make sure it's a working one?
Sorry, can you repeat?
I have a template. How do I make sure it's actually working?
Oh, all right. Okay, so we'll have a section to cover this on how to actually test the template. But let's start by looking at how we actually write a template. And before we just move on, I have seen a question in the chat about in which situation or use case would you pick up Terraform over CloudFormation? Well, it really depends. If you do everything in AWS and well, you don't have any reason to write infrastructure as code for different platform, then CloudFormation is definitely your preferred choice. If you, however, need to deploy infrastructure as code across multiple environments, might be a hybrid environment, might be a different cloud platform, it could be on premises, then and especially if you have already experience with Terraform, in which case that might be a good choice. So there's no there's no imposition. Ben, I don't know what's your viewpoint on this.
Yeah, the one thing
anything.
that I recommend people is to make sure you're comparing features and not directly comparing coverage. Sometimes you see online like people just making a list of these are all the resources that are covered in CloudFormation, these are all the resources that are covered in Terraform. You can add your own resources to both, so that's not always a really good argument. And they both have shortcomings on those on resource coverage. Just keep in mind that CloudFormation will actually give you a managed runtime to run and deploy your template. So everything the only thing you need to give to your end user, or that your end user has to set up, is a template. Whereas with Terraform, you also take responsibility of building that whole engine that actually will take that template or take the Terraform code and deploy that in your account. So be sure that you compare features there if you're going to pick between the two, and not just the things you can deploy with it.
And I see another remark in the chat. So I'm not sure it's a question. Rick saying, I'd like to have an idea of JSON versus YAML users. Personally prefer YAML because it's easier to root. And indeed, that's like I mentioned in the beginning, YAML is much better for humans. Definitely much more readable than JSON. So it's what usually people pick. But yeah, I'm not going to be religious about that. It's really you pick the language that you feel more comfortable with. So let's carry on. So if we look at writing a template, so the first advice that we really have is, well, take a proper IDE, take a proper code editor. It's really important. Don't just use Notepad. Which editor? Well, it's entirely up to you. I mean, Ben and I certainly use Visual Studio Code, but if you prefer Sublime Text, if you prefer to use Atom, Cloud9, IntelliJ, PyCharm, or any other out there, yeah, feel free to do so. The importance is that this editor, the editor that you choose, provides you enough features to support the addition of either JSON or YAML CloudFormation templates. And once you've done so, you can supercharge it. So you can add additional features to help to write the template itself. So, for instance, if you follow the link that is indicated here, it provides you with a configuration for that works at least in Studio Code and PyCharm to provide autocomplete. So as you specify a type of a resource in your CloudFormation template, you directly have suggestion of well, which type you're actually looking for. So to be quite honest, I don't know them all by heart. So it's really handy to have a list that you can choose from. Additionally, it also provides you some links to documentation. So that's so that you can, of course, well, dig further and see, okay, what exactly are the properties that are required for this type of resource? What do they mean? What should I expect as an output, etc. Next, we also have added here a link to a nice blog post which allows you to add even more features. So, for instance, one feature that is indicated here on the slide is if you have a long list of items, that can become well, extremely handy to be able to sort those items in alphabetical order, as simple as that. So, this. And a few other tips are contained on this blog post. It also, for instance, provides for at least for VS Code a couple of tasks. So tasks are commands that you can basically execute in the editor, and that provide, in this case, shortcuts to the CloudFormation documentation. So either to have all the list, or even to search an item by highlighting a type and searching directly documentation. So quite handy. So after you've written your item, it's like Ben mentioned, it needs to be tested. Sorry. So there are multiple things or tools that you can use to actually test it. So first, the command line. So you can use the AWS command line to test it. There is a validate template command that you can use. That's one thing. But there is even better. You can use a linter like cfnlint that you can install as a plugin in your preferred editor, and that will directly do the template validation for you. So you don't need to actually run that command line interface anymore. And you have other tools like cfnag and Sard. cfnag is good to actually test the security settings in your template, so to make sure that you don't leave things too open, some security groups with, for instance, too many open ports, or some wildcards that are used a little bit too often inside the template to give for access policies, for instance. And Taskart is another tool which is quite handy when you need to deploy your template, or at least make sure that your template can be deployed in multiple regions. Taskart will allow you to configure, for instance, a list of regions in which you want to test that your template deploys. So if you need to make sure that you need to share your template with people that will use it across, well, at least in different regions, then that can be really useful too.
Yes, and
I think that Ben has some tips for us.
Yes, I have some additional tips. The main one, if you remember anything from everything we're telling you here, is please use cfnlint. It will save you a lot of time. It's the first thing that I run if I get a template for someone. It says I have a problem, this doesn't work. Usually that will at least give you a direction of where to look. Will show you some things where you can improve things. And if you install the IDE plugin, like Patrick said, then you don't even have to think about it. Then you just get that while you're writing your CloudFormation. And you can even supercharge that a little bit. There are rules that are not enabled by default, some experimental ones. You can append your own rules. So, for example, if you want to enforce tagging in all your templates, you can write a rule that checks if tags are present on every resource. And there are also some informational checks that you also can include to just get more out of it. There was also a question a little bit earlier about how do I avoid writing circle dependencies with my templates, or if I have one, how do I debug that? There's a very recent feature in cfnlint, which is the build graph option, which will take all your resources, so it's only taking the resources, not the parameters, and it will try to give you a visual representation of how everything is connected together. That gives you two things. On one hand, cfnlint now will actually warn you if you have a circle dependency before you start deploying, because they know that graph. On the other hand, you can, the output is a file in dot format, which is a text file. There are a lot of online tools or CLI tools that can convert that into an image. For example, I used sketchviz.com here for this one, and you will be able to visually debug how things are connected together and find out those problems before you actually start deploying things. So we already had some great questions. Another reminder, if there is anything that you want to know more about, please let us know. Even if we're not asking them directly, we will still have time at the end where we will look at some questions, and we will definitely, even if we don't have enough time there, send you an email with some follow-up, so to make sure that your questions get answered. But let's first talk a little bit about how you actually deploy a template, which also ties really nice into a question I saw previously about do I deploy things by hand, do I go into the console, or do I use CI/CD, work around least privilege, things like that. The first step is like we saw in the beginning, in the whole beginning is go to the AWS console, upload your template there, click on deploy, you get an interface where you can put in those parameters, you can get an overview of everything that's going to change. So that's really the easy way to get started if you're developing things. Definitely the most user-friendly if you have nothing set up at all. If you are going to do a lot of deployment, a lot of iteration, it might make sense to use the AWS CLI, so you don't have to log in every time, you don't have to click as much, you can make it a one-command thing. There's AWS CloudFormation deploy command, which is actually quite smart because it knows the difference between creating a new stack and updating an existing stack, and will do the right thing for you. It has some additional options that you can also use there. So you can, the same things that you can do in the console, like adding overrides for your parameters or specifying parameters to not be the default is something you can do. You can add tags like you can do in the console. And there's also the option by default, the CloudFormation deploy will just take your template and do the update and deploy everything. But you can also tell it to wait, to not execute everything, but to show you a change set, so an overview of everything that it will try to do, so you can judge that before it actually runs. There's a whole lot of options, and there's all documented in the CLI documentation. So that's great if you're working on your own. If you want to give that same capability to other users who are not writing their own templates, but are just going to use templates, then you can also use the built-in integration with Service Catalog, where you as an administrator will write the template, upload that to Service Catalog, so that will store your template in there. You can add some extra rules in there, some extra constraints. For example, I can write a template where I allow everyone to use any instance type they want, but I can then upload it to Service Catalog and restrict my users to, for example, only be allowed to put in T3 instance types and nothing else. So you can add some extra constraints in there. You can limit which users can start which template. So that's a really nice way to distribute things as an administrator. From the user side, they get an overview, get a list of all the products, all the templates that are available to them, and they can see the ones they deployed previously, update them or terminate them, or they can pick a new product and then put in parameters if that's needed to personalize it, and then deploy it in the account. So you get some extra control there. You know that they're deploying things that are built according to your best practices, that they will can be tagged the right way, that everything is there the way that it should be, while the end user only needs rights to use Service Catalog, and Service Catalog will can make sure that everything actually has rights to start at CloudFormation and to put everything in the right place. You don't always want to do that. Sometimes you just want to have an actual application that's going to be deployed once. And there, it's most of the time makes more sense to look at CI/CD and integrate this in your either your existing pipeline or in a new pipeline, where you leverage, for example, AWS Code Pipeline, which also has a built-in integration with CloudFormation and even with change sets. So where you can make sure that it's automated, repeatable, that it's safe to deploy. You can add, for example, a build step in there that will actually run CFN lint another time, run CFN nag, just to be sure that people don't forget to do that on their side. And you can also you can lock down access, so you don't have to give people access to your AWS account. You can make sure that they only get access, for example, to publish to code commit or to GitHub, and then it will trigger the pipeline when there's a change in your master branch, and it will do all of that without giving end users access to your own resources. And then a last way where you might want to deploy things is if you're working with either multiple regions or multiple accounts. And for that, stack sets is a really nice option, where you, just like in Service Catalog, upload a template to a stack set, create a new stack set, and then you can link that stack set to different regions and accounts. And then CloudFormation stack sets will deploy that template in every region and every account that you specify. So you get the same template everywhere. You can still override some parameters in that stack set, so you can make sure that some accounts maybe have a different configuration or a parameter that's a little bit different from the others. And you can update that template centrally, so you, if you have a new version of your template, you update the stack set, and then CloudFormation will roll that out to every region or in every account. So that's great if you want to have a baseline with certain resources in every account, or in every account of a certain organizational unit, or even in every account of a certain list of accounts that you build yourself. If you're using organizations, you don't even have to specify that list yourself. You can tie stack sets to either your whole organization or to a specific organizational unit. And in that case, CloudFormation will take care of deploying those resources in that account when you move it to that OU. So it's something where you don't even have to really think about it anymore. You can just be sure that those resources and those stacks will be deployed in the account when you spin it up. And then we have some tips from Patrick related to this.
Yes. So the first tip is pretty useful when you need to share, for instance, documentation with multiple users, or you're preparing a workshop and you want the people to consume the stack really easily. So you can have a quick link to deploy your stack just with one click. So that's pretty handy, like it shows here in the example. The second tip is to make sure that you really use change sets to validate what CloudFormation will do once you update your template, so to understand the impact that the changes it will make will have on your stacks. And well, the second part of it is that you can also use, if for instance you have an approval process inside your company, when it's not the same person that does the changes in the template or creates the template, and then the person that will actually bring those changes into production, maybe you have an approval process. So you can generate the change sets that will be at some point approved by someone else and executed in a different environment like production. So as an example, start this. Here we see a stack where a couple of changes are identified in these change sets that is displayed on the screen. You can see that we have two routes, one of which is modified, the other one is going to be removed. We have two NAT gateways that are changed, and a new security groups that will be added. So that's a pretty handy way to understand, okay, is my template behaving the way I want it? Is the end result exactly what I expect it to be? So we mentioned that so far we're using CloudFormation to deploy infrastructure, and that's true. That's really the main objective. But you can also use it to deploy software if you want. So you can use a transform like SAM to actually deploy serverless functions on AWS. You can use also CloudFormation in it. So we mentioned earlier on that there was a metadata section in the anatomy of a template. So you can, in that metadata section, document the CloudFormation init instructions that will be actually executed once you launch your EC2 instance. The same way you can use other things like auto-scaling groups, and in particular their update policy to decide how CloudFormation will behave with your auto-scaling group, with the resources managed by your auto-scaling group when you trigger an update on your stack. And so on and so forth. So there are multiple ways you can leverage code deploy. You can leverage condition weight handles also to make sure that the code, for instance, or some instances get configured once the infrastructure that you expected to be in place is in place and not earlier. The second thing that is also to be noted is you have multiple ways to pass the right privileges to the different resources to actually deploy the resources documented in your template. So the first thing that well everybody normally uses and knows is the service role. So you associate a service role, or you give a service role to CloudFormation, and you provide the right privileges to CloudFormation in that service role to actually manipulate the resources that need to be deployed. So in that example, it could be DynamoDB, it could be that the data needs to be decrypted, and then it needs to also access the right actions on KMS. But you could also use the called via instruction to actually attach the accesses directly to the user or to the role, well, to the IAM principle in substance, that actually will launch the CloudFormation deployment. So in that way, you make sure that the end user does not directly touch the resources, but he is given the permissions to touch those resources only through CloudFormation. So that's the called via instruction. Now it's the moment for questions. I think there were previously a few questions in the chat. I've seen, I tried to answer a few.
Yes.
There are still some open, I believe.
I've seen some about CI/CD, one about using permissions. For example, you touched on that a little bit with
Yes.
the service role. Just wanted to add that you can, so you can give a service role to CloudFormation and only give your end user the right permissions to update CloudFormation, which will already allow you to scope down your permissions quite a lot because it only needs to be able to update those stacks. But you can also use service roles, and I think that's even the only way, with code pipeline. So the built-in integration between code pipeline and CloudFormation, you don't actually have to give your end user the rights to deploy CloudFormation. You give code pipeline those permissions, and then you give also code pipeline the permissions to check if you have new code on your master branch. So you don't have to store any credentials outside of the things that code pipeline stores. If you're using some other CI/CD tool and you want to work with permissions there, then it will really depend on your tool. I would recommend trying to use those service roles for CloudFormation, so you don't have to store access keys and secret keys for things that have full admin permissions in your environment somewhere outside of AWS. In the same way, look at how your build tool handles that. Most of them have support for kind of secret management there, so it doesn't. So you don't have to put those credentials inside of your source code or inside your template where they might leak outside of what you're actually trying to do. I think there were other questions also. Did we cover most of it?
Yes, I think there's a question about additional information, how you handle a pipeline to manage multiple environments and deploying across multiple accounts. I think in the links that are included in the presentation, you'll find some of these examples. The landing zone solution is a great example of such a solution that leverages code pipeline to actually deploy resources across multiple accounts and multiple environments.
Yes. In the same way, the AWS there's another AWS Labs project that does the creates code pipelines for you. The name is escaping me for a moment, but it also uses that kind of same creating one code pipeline and then deploying into multiple accounts with that pipeline, for example, starting with the deploy, doing first deploy to all the sandbox accounts, and then doing it to all the dev accounts, test accounts, and so forth in one pipeline, so you know that it only will go to the production account after it has deployed in the sandbox account and the test accounts. And I think we can continue with that?
Yeah, we can probably continue in the interest of time, and we'll come back to the questions at the end. Hopefully, we'll have some more time. So next, okay. So, well, resources. There are a number of resources that are supported by CloudFormation that you can leverage to actually deploy your infrastructure. But what if what you're trying to achieve is not there? So recently, the CloudFormation team has made their roadmap public. It's quite handy. It's available there on GitHub, like it is for other AWS solutions. So you can directly see exactly what the team is working on, what is coming soon, what is just shipped, and things that maybe they are still researching and that have not made yet their way to their roadmap. And if the feature that you're looking for is not there, of course, feel free to actually create a new ticket to actually document the resource that you're looking for. So I took this example where someone was looking for support for the Glue workflow, which has now been shipped. But yeah, then specifying exactly what you want, documenting what the feature should do, etc. And of course, if someone else has documented already the feature that you're looking for, it's important to upvote them so the team knows, based on the number of requests for each feature, how to prioritize them.
Yes.
And I think Ben has some tips for us.
Yes, I would recommend taking that even that roadmap idea even further, and to say it in a more concrete way. Don't complain about AWS where AWS can't hear you. So if there are a lot of teams who have roadmaps by now. I think there are 4 or 5 of them. If you use Twitter, you can use AWS wishlist. You can raise support cases. You can use the forums if you want. You might have an account team where you can reach out to. Just make sure that if there is anything that you miss, either in CloudFormation or on any other service, that you actually complain about it and complain about it to AWS, because they build their features based on customer feedback. So make sure they actually hear that feedback and can start building for you. If you can't wait on them building it, then you of course will have to build something yourself. In that case, with CloudFormation, there are 2 big options. So you can, in both cases, the solution there is to create your own resources. That can be to fix a gap that's in the AWS coverage to support an AWS resource, or that can be to configure your own service. If you have a SaaS or something internally that also needs some configuration that ties in with your CloudFormation template, then you can actually trigger that from inside CloudFormation and have CloudFormation manage the lifecycle of that resource. So the 2 big options are custom resources and resource providers. Custom resources are the older way to do it. Works by you write a Lambda function that you deploy in your own account, and then it will get triggered by CloudFormation. There are lots of libraries to help you with that. There are blog posts. If you deploy it in one account, it's most of the time you will do something like the service application model to build and deploy that. If you do it in multiple accounts, it's pretty straightforward because you can use the same CloudFormation tools that we talked about before to, for example, use stack sets to make sure that the resources you write are available in all your accounts. There are some best practices, but they are mostly in documentation, so they are not enforced, so you need to be sure you check them before you start writing. But it's pretty easy to get started. With the downside that everything that's possible in it right now is everything that will ever be possible in it. So there are no new features coming in there. It's just going to be that. One of the things that, for example, is pretty difficult to build on your own there is something that needs to be longer running than the default runtime of a Lambda function, where you have to do things with callbacks and manage that whole process yourself. On the other end, there's now also the resource providers, which is a newer way to do it. Which gives you your own namespace to put your resources in, so you can be a little bit more like how CloudFormation natively works. The runtime is not your Lambda function. You make a zip, give that to CloudFormation, and they will run that in an AWS managed runtime. So it's also more future-proof. You have to write a little bit more code, but it will give you, if there are going to be new features where resource providers are going to be even closer to native CloudFormation, then it's going to be there. Deploying in multiple accounts is still a little bit harder there. That it's coming. There's a GitHub issue open where there's a lot of talk about how it's going to come. It's on its way, but until there's native CloudFormation support, it will be harder to deploy it in multiple accounts. Deploying the one account is very similar to custom resource. Instead of best practices, because well, they're not as much best practices because it's relatively new, but it has built on top of the lessons they learned from custom resources. And for example, they now have contract tests, so they will actually test your resource provider before you upload it to make sure that it's actually behaving similar to how a native CloudFormation resource would behave. In the end, that means that the initial effort to get started with that and to write your resource provider is a little bit higher, but the potential in the future is also a lot higher. What does that look like? Custom resource looks like this, where you have a type that starts with custom. You have a properties. You can pick your own properties, and that will all those properties will be passed to your Lambda function. But one required property is a service token. And that has to be either a Lambda RN or an SNS topic. And it's impossible to change that without deleting the resource. So that's the way how it kind of locks you into that deployment method where you can update the Lambda code as much as you want, but you cannot decide to make it another Lambda function once the resource has been deployed. CloudFormation supports 3 actions it can send to that Lambda function: create, update, and delete, which happens on those stages in the lifecycle of your resource. And then you're responsible to writing the code that actually does those things. For resource providers, you only have to specify a type. You don't have to set a service token there, which means that you can manage how you deploy and add new resources and things like that outside of your template, which means completely independent from that. You also get more actions that you have to implement. Instead of only create, update, and delete, you also get a read and a list action, which is not currently used by CloudFormation, but it will unlock features in the future, like chain sets, maybe imports, things like that, where CloudFormation would have to know the actual state of the currently deployed resource. Besides that, it works very similarly. You still have to write your handler that does the code itself, that actually provisions everything or deletes everything or updates everything, but it's closer to how the real CloudFormation works. It's also a little bit easier if you have long-running events where it can actually keep polling your Lambda function instead of you having to keep everything running yourself. And Patrick, I think you have some tips around that.
Yes. So the first thing is about how you organize your custom resources. The advice is to use a separate stack. Well, try to avoid dependencies between the current stack and the custom resources that you need to create. Maybe they have a different life cycle than the resources in your stack, and we'll come back on how, I mean, the advice, the tips that we have to on how to organize your stacks a little bit later. The second advice is to leverage helpers to actually create your custom resources. Why? Because as it's shown on this slide, there are a couple of well, first documentation, then one example that shows how to use it, because it deals with the complexity for you. So the helpers already deal with how to manage to respond to CloudFormation, how to handle exceptions, how to handle timeout nicely. It may be that at some point you need to create resources that take, for instance, more than 15 minutes, the maximum lifetime of a Lambda function. How do you do them? Those helpers are there to provide answers that it can create. In this case, for instance, schedule events and in CloudWatch events to actually provide a solution to that problem. So they're really, really handy. So that's really an important best practice. Next to that, So yes, resource providers are apparently. I've not tried that myself. Maybe Ben has, but they are also handy to use Terraform in CloudFormation. So you will find some examples, some providers that are already what are managed by AWS are available on GitHub. If you just follow the links that are indicated here, you will find additional information on this. And yes, this is simply the page that you land on once you basically follow the link, and gives you, well, first link how to use Terraform inside CloudFormation, and the second link on the AWS resource providers available. So let's check on the questions before we move on.
Yes. I've seen some questions about nested stacks and things like that. So I propose we move on immediately and try to come back to questions
exactly.
Later, so we can
we'll
cover as much as possible in the 5 more minutes I think that we have from this hour.
Okay, all right. So how to structure your stacks? So important is to, well, an advice is to structure them by layers. So make sure that you organize them basically by life cycle. So different resources has different life cycles, so group them by life cycle. That's much easier that way. And then you reuse those stacks and the different layers across all the environments. So that was one of the first tips we mentioned. And so manage your CloudFormation templates exactly like you would manage code that will roll out to multiple environments. Now you would say, okay, if I start creating resources one way and then I realize it's not exactly what I should do, what I should have done in the first place, how can I get out of it? So you have the possibility to always orphan resources out of a stack. So you can leverage deletion policies for resources. And so for instance, you have a DynamoDB or another resource that is attached to a stack that you want to take out, you can specify a deletion policy of retain for that resource and delete the stack, and then you will basically get an orphan resource that you can import into a new template. So not all resources are currently supported for imports. Those on the slide, plus a couple of others, are currently available to follow that path. And then pay attention also to imports and exports, because if, for instance, you have stacks, you export some resources from the stacks that are consumed by another stack, then you're pretty much tied. Those resources are pretty much tied, and you can't delete them anymore. So the exported resources cannot be deleted if it is already imported by another stack. So points of attention there. And now there is the much demanded topic that Ben will cover of nested versus layered.
Have to tie them together somehow. There are 2 big approaches to that. You either create every layer as a completely separate stack, what we here call a layered approach, which is the default I would recommend, because it makes it very easy and safe to update one stack at a time, with the downside that you have to make sure that you do the updates yourself in your pipeline or your CI/CD tool. On the other hand, you can also create CloudFormation stacks as resources in CloudFormation. That's what we call nested stacks. You will sometimes see people recommend that. The big downside of that is that the child stack will always update if you update the parent stack. So you don't have control about which stack will update which time. It will always get the latest version of the child template and do that whole update. Similarly, it doesn't have support seeing change sets in a nested way, so you will not be able to see if there's actually going to be a change in that template, in that child stack, or if it's just going to be a no action update. There are some cases where you want that, where you always want the updates of that child stack. In that case, nested stacks are better. I would recommend starting with a layered stack or a layered approach when you do that, when you start splitting up templates. If you start splitting up templates, you will also have to tie them together somehow. So for that, there's input and output. The most simple way to add an output is use the output section, where you give it an output name, a value, and a description. This is very useful for humans. If you want support other stacks to actually import that, you don't want to be copy-pasting things around. For that, you can, one of the options, there are two big options. One of them is using exports, where you give that output an exported name that can be hard-coded, or it can be using those pseudo parameters. And then you can import that later. And once you import an export, it also logs that value of that export, so it cannot be changed. That's perfect for things like subnets that you don't want to be deleted while it's in use by another stack. Another way to export or to put outputs outside of your stack is using SSM parameters. SSM parameters in SSM parameter store is just a separate service. So you do that by adding an extra resource in your template where you give it also a name and a value and a description, and then you can use that anywhere you want inside your application or inside another CloudFormation stack. And if you want, yes. So inputs the other way around. We talked about parameters in the beginning, where you just have something where you can type something in. This is copy pasting. It's not that useful. You could do that with your CI/CD tool, of course. Another way to do that is actually use that export, and you do that by adding the import value, and then that will log that export value to be used inside of your template. If you did it like the first example, where you added the stack name inside of the export name, then you can add a parameter and use sub to be able to select the stack you're importing from with only one parameter and have multiple imports. If you don't want that locking behavior, for example, if you have something that might change and it doesn't really matter if it's in use or not, then you can use those SSM parameters and import them with, for example, a resolve. Resolve is also supported is also support for secrets manager, so you can also import external secrets that way. So you add the name here of the resolve, you can add the version here of the resolve, and you can also use sub with this. So you can actually add a parameter to select the stack here. The one downside is that there's no support for using latest as a version. You also have to always have to have a specific version. If you don't want that, you can use a parameter which as type has alias SSM parameter value. That way, there you cannot add a version, so that will always get the latest version. You cannot use a sub to specify which SSM parameter has to be written. That has to be put in by the user. It has to be read, sorry. But this will also get the latest version. One thing to keep in mind for both of those, if you use it either as a resolve or as a parameter, is that the actual reading of the parameter out of SSM will only happen once you read once you update the stack. So there's no automatic trigger from SSM has been updated to almost text update. It's SSM has been updated, and then at some point you have to update those stacks to get the latest value from that. So I'm going to skip questions for a little bit because there's one more slide I want to show you, and that's how you learn more. Besides all the links we showed you before, there are official documentation. There's a best practices guide in official documentation. There's an awesome CloudFormation overview page that gives you lots of links to different resources. And there's also some best practices in the real-world serverless application that's available on GitHub. I think we are almost out of time. So we have one last poll for you before we try to tackle some questions. And that is, what should we talk about next? So we talked about writing them, testing them, deploying templates, those resource providers, some things where we can definitely go in deeper. There were a lot of questions about CI/CD, so I think about deploying. There's also space to go deeper in that, but you want to use want to know that from the audience. If you're going to do a follow-up presentation, where should we focus on? So please vote on that. Yeah. And then with that, there's maybe still some time for questions. If we're running out of, there's 1 minute for questions. Don't worry if you have to go, that's fine. You've seen everything there's to see. We will probably stay here a little bit longer if there are still questions. So you if you don't be afraid to ask them anyway. But if you have to go, I don't think you will miss any of you will not miss any more slides. So let's see about which questions we have. I have a question about if you never used CloudFormation before, should I start with CloudFormation, or should I look at things like the CDK and focus on that and learn in that way? So where should I invest my time if I'm starting anew right now? I'll give my opinion first, Patrick, and then you can correct me if you don't agree. I would recommend using CloudFormation anyway, or at least start with that for two reasons. One of them is that CloudFormation will actually give you the as a direct link between what you write in your template, what you see in the output from what CloudFormation creates, and what actually gets created in your account. So that gives you, if you have to debug something, which will happen, you don't have to switch mental models. You can just look at your template, look at what's actually created in the account, and see if that matches or not. If you use a CDK, that's going to be harder because the CDK will hide that from you. And you will actually have to switch from the programming language you know to still reading CloudFormation templates to know what actually got created, and you will not have that experience yet. The other reason that I most of the time recommend CloudFormation is that I've used things like CDK before, for example, Troposphere, and I've made a lot of mistakes myself that way by being too clever, and the risk is just higher that way. I don't know if you have something to say about that, Patrick?
Well, my own experience with CDK has been rather positive. I mean, I had errors also. I tripped on a few mistakes I made on the CDK, and then it was, like you mentioned, not that easy to actually debug, because indeed it generates another language, and then you need to look on the output to understand what's going wrong. But on the other hand, if you're for instance POCing a very small environment, and the resources that you need are supported by CDK, it's extremely easy to get it done with the CDK.
Yeah, I think the CDK is a good tool.
It gives you more control on everything.
Yeah.
It
definitely solves a problem. If that's something you want to do as a global approach is another discussion, of course. I think we run out of time. We'll definitely look at all the questions later, so expect an email from us with responses to that. Thank you, Patrick, for joining me. Thank you, everybody who watched. It was really nice to do this.
Thank you, everyone.